Hello, everyone. This we are the group four, and my name is Juriel Ainroy Bitapunggot. And together with Dan Lester Mier, John Rome Luna, Jeff Henson Semene, Ervin Zalsos, and Jomar Saldares, we will be discussing about topic four, dryers and drying process. So let's talk about the overview of the whole report. I will be discussing about the introduction to drying process, and the next one will be discussing about the kinds of dryers. The spray dryer, one of its kinds, will be discussed by Dan Lester Mier, and along with it is its definition, working principles, and applications. That is actually our main format as we go over about the other kinds of dryers. Next is the oven dryer or the Klin, which will be discussed by John Rome Luna. The freezer dryer will be discussed by yours truly, Juriel Tapungot. Vacuum dryer, which will be discussed by Jeff Hansen Simene. Rotary dryer, which will be discussed by Ervin Zalsos. And lastly, the drum dryer, which will be discussed by Jomar Saldares. Let's first define what is drying. Drying is an operation in which a liquid, usually water, is removed from a wet solid in equipment termed as a dryer. Separation can be carried out either mechanically or thermally. We have two types of drying here, which is mechanical drying and thermal drying. Mechanical drying consists of a machine that has a rotary member. One of its example is rotary dryer. Its its analogy is like this. Kung magsampay ta og usa ka sanina lugar, ato na siyang gayabyabon. Pagyabyab ana ni mga wala nga tubig. So that in itself ang pagyabyab nimo is one of the example of mechanical drying. Muna siya iyang main working principle where ga exert ta og force, para actually physical force para makakuanta og makadry ta og usa ka material. Well, if we talk about thermal drying, we're talking about heat transfer. Heat transfer in a sense where we're talking about conduction and convection transfer. Radiation heat transfer is actually out of the question because most of our drying products is food, o kung dili food, pharmaceutical products. Of course, we don't want any material nga radioactive. Kung mag-consume ka ng radioactive product, di man na siya pwede. Delikado man na. So, as we continue, drying can be described by two processes operating simultaneously. We have first the energy transfer from an external source to the water or organic solvent. In this case, direct or indirect heat transfer. Direct heat transfer, we're talking about conduction, and indirect transfer, we'll be talking about convection. And the next one, the phase transformation of water or solvent from a liquid-like state to a vapor-like state. In this case, it is known as the mass transfer of, of, of liquid to most likely to gas. Ay, sila mo exit dayon sa usa ka material nga gidry. In some cases, we're talking about sublimination, in which from solid, mahimo din siyang gas, in which will be discussed later in the freeze dryer. So let's proceed on the kinds of dryer as I pass the mic to Dan Lestermier.
Hi, my name is Dan Lestermier, and let's begin with spray dryers. Now, spray drying is a method of producing dry powder from a liquid slurry by rapidly drying with a hot gas. It uses some type of atomizer or spray nozzle to disperse the liquid or slurry into a controlled drop size spray. It can dry a product very quickly compared to other methods of drying. This is the parts of a spray dryer. You can pause the video here to analyze the figure. Let's discuss the Let's discuss the working principles of a spray dryer. The spray drying process consists of the following processes. First, concentration. It is the increase of solid content by reducing the amount of liquid that must be evaporated. Next is atomization. This increases the surface area for optimum evaporation to lead to a dried product having desired characteristics like particle size, shape, and density. The droplet air content. Atomized liquid is brought in contact with the hot air, mostly composed of oxygen and nitrogen gas, in the drying chamber. This results in the evaporation of more than 95% of water. The way in which spray makes contact with hot air influences the behavior of droplets in drying phase and directly affects the properties of dried product such as size, shape, and density. The droplet drying, in this process, the moisture evaporates in two stages. First, water evaporates from the surface is replaced by more water molecules from the bulk. The next stage begins when there is no longer enough moisture to maintain saturated condition at droplet surface. This causes dried shells to form at the surface. The rate of evaporation falls and shell thickness increases. Then, in separation, first, in primary separation, heavy particles simply fall at the bottom of the drying chamber. Small fraction of fine particles remain entrained in the air. Next, secondary separation will take place as it enters the cyclone separator and electrostatic precipitator. In the final separation, filter bags or wet scrubbers are used to purify and cool air. The application of a spray dryer includes food, pharmaceuticals, and industrials. Thank you.
Hello everyone, my name is Jerome Luna, and the second type of dryer that we'll be talking about is the oven dryer or kiln. About the material. A kiln is a thermally insulated chamber or oven in which a controlled temperature regime is produced. A drying oven is a device for applying low heat over a long time to a variety of objects for a variety of purposes. Applications of an oven dryer or kiln. Toilet bowls, syrup pipe, tiles, glass, and porcelain. Also used to manufacture chlorine gas and also for curing rubber and plastics. So here's a video showing how an oven dryer works. So the next reporter to talk about the next kind of dryer will be Real Topong.
Hello everyone! Ani-anasal ako to discuss about freeze dryer. So, a freeze dryer is a device used for freeze drying. Of course, given, since we're talking about freeze dryers, we'll also be talking about freeze drying. So, the result is a product that can be stored at a room temperature for years without spoilage or packed in limited storage spaces and reconstituted with water later. One of the examples of this is astronaut food. Sa outer space, dili ta dali makaluto. For number one, walay air. Number two, aglutaw ang mga gamit. So with that, given those, ang mga astronauts gasalig lang sila og mga ready-made food, which are usually freeze-dried. E kani mga freeze-dried nga mga pagkaon, most likely fruits, gina-reconstitute lang, ginabutan na sila tubig, then they're ready to eat na. At the same time, they're also healthy for the body. Freeze-drying is also known as lyophilization. Again, it's known as lyophilization. And lastly, freeze-drying is a dehydration process typically used to preserve a perishable material or make a material more convenient for transport. One of the property of freeze-drying, aside sa ma-preserve niya ang pagkaon, is dali din siya mas dali siya i-repack. Kay one of the reason for that is mas gamay ra siya space nga kaunon, because of course kung i-dry nimo siya mawala ang tubig, mukuyot na siya. Pag kuyot ana, dali din na siya sa usa ka sudlan ana daghan na ma-store, daghan na mabutang. So before we discuss about the working principle of freeze dryers or freeze drying rather, let us go and watch a very short video about freeze drying working principles.
The freeze dryer freezes the food to 40 degrees below zero. The vacuum pump automatically turns on and creates a powerful vacuum around the food. As the trays gradually warm, while the food is still frozen, a process called sublimation occurs, which removes water from the food. This is what allows the food to keep its original shape, flavor, and nutrition. The process takes between 20 to 36 hours. Smart sensors determine when the food is completely dry and alert you with a beep. The process is entirely automatic.
So we're done with the video. Let us proceed to the thorough discussion of freeze-drying working principles. As we read, the process of freeze-drying includes number 1, cooling, which is defined as lowering the temperature at about minus 40 degree Fahrenheit. You might be asking, why is it to be cooled at negative 40 degree Fahrenheit? Why not absolute zero? Well, the reason for that is para dili mag-perish ang mga microorganisms nga nag-exist sa usa ka material nga imong gi-dry. Most specifically, mas effective ni siya kung mag-freeze dry ka o ka ng mga plasma. Blood plasma is actually a living organism at its own right, because it delivers blood in different parts of the body. So of course, kung imo na siyang i-store at absolute zero, magka-hypothermia siya. Therefore, mamatay ang nga blood plasma. The second process is known as vacuum chamber. Vacuum chamber automatically turns on and creates a powerful vacuum around the food. So, kuan na siya, nag-heat na siya. Aside sa air, naana siya water vapor. So, kana nga air and water vapor nga mixture, so yupon na siya sa vacuum chamber para mahimong effective ang atoang drying process. The third one is sublimation. Sublimation, as the tray gradually warm while the food is still frozen, a process called sublimation occurs which removes water from the food. This is what allows the food to keep its original shape, flavor, and nutrition. Sublimation is defined as heating solid to gas. Di na siya mag-agi sa liquid phase. Since ang water is gi-cool na to at negative 40 degree Fahrenheit, na parts ana nga nahimo na siyang ice. Pagka ice ana, ato na iagi na siya sa sublimation, pinaagi sa tray sa ilalom nga gainit. Tungod ana ga sublimate siya, mahimo siyang vapor. Og of course, ang vacuum chamber so yupon niyang mao nga vapor pagawas sa atong system. The last aspect of the freeze drying in which we will discuss is the freeze drying application. So, as we read, pharmaceutical companies use freeze drying to increase the shelf life of products. One of the example of this is the lagundi. Ang lagundi is actually not dried at a certain means nga we know nga atlo siyang ibulad. There are some instances nga ang lagundi is gina-freeze dry para mas magdugay iyang shelf life. At the same time, dili dali mawala iyang potency. Because as we all know, it will be frozen at negative 40 degree Fahrenheit. Nga ang uban nga mga portion ani such as vitamins is dili mag-perish tungod ani nga temperature kay wala siya gi-freeze at absolute zero or near absolute zero. It is also used in foods such as instant coffee, astronaut food, as I told you earlier, freeze-dried fruits, and cereals. In technological industry, freeze-drying is often reserved for materials that are heat-sensitive such as proteins, enzymes, microorganisms, and blood plasma. Kay kung kani nga microorganisms and blood plasma, some other proteins and enzymes as well, ipaagi nato sa absolute temperature, mga matay na sila. Di na sila may effective hinoon kay patay naman, of course. So to prevent that, they have been frozen at negative 40 degrees Celsius o ginadry siya at the same time kaya para dali para pag-revive, dali ra. Okay, ato ram na i-reconstitute by water later, so dali din siya mag-revive. It will be the same thing, it will be almost the same as wala na siya nahilabti or wala na siya gi-process. So I'm done with my part about freeze drying. Let us proceed in vacuum dryer, which will be reported by Jeff Henson Semene.
Vacuum dryer can be used for delicate materials and save up significant energy quantities due to lower drying temperatures. Vacuum drying is a process in which materials are dried in a reduced pressure environment, which lowers the heat needed for rapid drying. It does not take the place in a true vacuum despite the name. Vacuum drying working principles. Phase 1. Preheating. Preheating the vacuum chamber in 20 to 40 minutes. Phase 2. Vacuum drying. The pressure in the vacuum chambers is reduced from 760 mmHg to 80 mm mercury. Also, the boiling point of water is reduced from 212 Fahrenheit or 100 Celsius to 113 degree Fahrenheit or 56 degrees Celsius. The material is dried to target ppm by vacuum in 15 to 20 minutes. Phase 3. The materials delivery. The taking of dried materials out of the chamber. Vacuum drying application. Commonly used for drying thick, hard, and other materials. In the vacuum drying process, the material to be dried is subjected to a reduced pressure environment, which reduces the boiling point and aids evaporation of the water or capillary transport. The targeted supply of heat and pressure control optimize the drying process. Another positive effect is the low energy cost, as the vacuum makes it possible to dry materials at very low temperature.
Rotary Dryer. A rotary dryer is a device that uses rotation, gravity, and warm gases to dry a material. Rotary drying is a direct heated dryer that uses the combustion of gases generated by the heater mixed with an artificial heated gas. The second gas is nearly always common air, but it can be inert. The rotary dryer, also known as a tumbling dryer, is an equipment employed to minimize the moisture content of feed materials by bringing it in direct contact with a heated gas. It consists of an inclined long drum or cylindrical shell, often fitted with internal flights or lifters, which, rotated slowly upon bearing through which the materials to be dried, will flow in a tumbling or cascading action in concurrent or counterflow with the heated gas or gases. Here is an example of co-current rotary dryers. In co-current rotary dryers, the feedstock has a similar direction of flow of the inlet gas. Co-current dryers also are the most widely used and are particularly suitable for drying materials containing a high moisture content, which are heat sensitive or have a tendency to stick or cake. The wet material is in contact with the gas at its highest temperature, which rapidly evaporates surface moisture. The initial heat transfer rate is high, causing an immediate and considerable drop in gas temperature, which prevents overheating of the materials and the dryer shell. The final product is in contact with the gas at its lowest temperature, enabling the moisture content to be readily controlled, usually by maintaining the dryer exhaust gas temperature at the preset value. Here is an example of countercurrent rotary dryers. In countercurrent rotary dryers, the feedstock has an opposite direction of flow with the gas. Countercurrent rotary dryers are more suitable for materials that must be dried to very low level of moisture, where the last traces of moisture are difficult to remove, or where the elevated product temperature is desirable. They are also used effectively as combined dryer or preheaters. However, since the final product is in contact with the gas at its highest temperature, the countercurrent dryer is often unsuitable for heat-sensitive materials. Although this system can be more efficient, the moisture which is to remain in the product is not steadily controlled. The difference between co-current and countercurrent rotary dryers is that co-current rotary dryers has a similar direction of flow of the feedstock and the gas, while the countercurrent rotary dryers has an opposite direction of flow. Also, the co-current rotary dryers uses a heat-sensitive materials, while oftenly countercurrent rotary dryers are not suitable for heat-sensitive materials. Applications of rotary dryer. A rotary dryer is a device that uses rotation, gravity, and warm gases to dry a material. This dries ranges from small household clothes dryers to large industrial systems. Regardless of their size, the majority of the rotary dryers works the same way. An example of a large industrial systems, according to Qingdao Pallet Machinery, is that rotary drum dryer is especially designed for drying a sawdust, wood shavings, wood chips, wood blocks, rice hull, chicken manure, grass, bean dredges, cassava residues, and sludges.
Thank you, Irvin, for that comprehensive discussion on Rotary Dryer. Hi guys, this is Jomar Samban Saladares, and I will be discussing the last kind of dryer, which is the drum dryer. What is a drum dryer? Drum dryer is a rotating cylinder that uses steam or hot air to heat feedstock and reduce the moisture content during a manufacturing process. So it is somehow related to rotary dryer since it is rotating. Hence, drum drying depends upon the products it will be processing. A drum dryer also is typically made from cast iron or stainless steel, as you can see in the picture here. The length of time the feedstock remains moisture content and the desired ending moisture content. This is the working principle of a drum dryer. It consists of one or two steam-heated rotating drums, there in the picture. A gas, normally air, may be blown over the surface for quick removal of moisture. The feed, a solution, or slurry forms a thin layer on the drum. The dry product is scraped off as flakes of 1 to 3 millimeters thick from the drum surface by a knife. The speed of rotation in revolutions per minute varies between from 1 and 24 RPM or revolutions per minute. The drying rate is high about 10 to 30 kilograms per meter square per hour and the drying time is low about 3 to 12 seconds. So, asa kagamiton ang drum dryer? So, this is the application of a drum dryer. These are the products that are being made or produced out from it. So, we have here the powdered milk, starches, breakfast cereals, baby food, and instant mashed potatoes. So, here's a video on how a drum dryer works. So that's all about drum dryer, and this has been Jomar Samban Soldares for the report.